The okay, so with same thing, the main idea is that again, someone, at least one person has volunteered to donate their notes, so I can post them to the benefit of whoever cannot make it. It's going to be the same, because again, just to clarify, what I offer on Monday will be the same. So it's not like part 1 and part 2 will be on Monday. The only difference would be I might be wearing different clothes and maybe go over a few different examples, but the same topics, right? So, and you know, I'll post whatever is handed to me. Just to emphasize the dates and the times and the format, it is on Tuesday at 7:30 in the morning. So please make sure put 3-4 alarms, because you know sometimes unfortunately it has happened where I've had students, well, I put my alarm, the electricity went off, I didn't wake up or whatever. So put battery alarms, have your parents call you, your friends, whatever. But please, be there on time. It's 80 questions, as I mentioned in class. It will be 30% true and false, 70% multiple choice, ABCD, E-type, ABCD. So when you're going over the exam, there are some that are 4 answers, some that are 5 answers. So if it's the last answer and it's only 5 choices or 4 choices, be careful what you put with D versus E. So if it's 4 choices and it's the last one, don't circle E. Because again, unfortunately this happens. The material will be largely presented in the order we discussed them, largely. The true and false might be scrambled, but there will be some question that would address more than one topic, and these can go anywhere. But 80 questions, and the 2 hours is more than enough. I've already broken down information for you. This has been on Blackboard for a while, but just to emphasize, Chapter 2, only part of it, up to the end of bright field. So the start of dark field, because all stains, as we will talk about now, all stains are on the exam. So bright field includes, positive stains, negative stains, capsule stains, etc. Spore stains, acid fast, all that. 3 is all of it. 5 is the only the chemotherapy part. 13, all of it. That's glycolysis and all that. Just kidding. See how many of you are paying attention. 13 is out. So 5, yeah, just 5. And then 7 and 8, I think. Sorry, 8 and 9. 7, 8, and 9. Okay, because I'm sorry, I'm also thinking about genetics and I forgot. But anyway, 7, 8, and 9. So molecular regulation is not on it. And then the 2 new handouts that we discussed. There's going to be more info from the old than the new. So this is just to give you a heads up. Now, just like I have done in the past in these meet sessions, there's no way I can go over the exhaustive list of topics. I will highlight what I think are the more important ones, but I would urge you to go back to the old meet session notes, because they would certainly help you. Questions before we start?
You said chapter 5. I thought you said 27.
I'm sorry, 27. It's not 5.
Okay.
It's 27, the chemotherapy. It was 5 in a... Anyway, mine wasn't even 5. I don't think it was 5. But anyway, right, it is chemotherapy. Right, that's what I meant. Right. So go with what I put on Blackboard, not what I just said.
You said 7, 8, and 9, no molecular regulation. Is not.
Molecular regulation is not. N-O, not. Not K-N-O-W. Sorry?
Just that part of chapter 7, 8, and 9.
Well, molecular regulation, wasn't it its own
Chapter 10.
chapter?
Yeah, it was chapter 10.
It was its own chapter, it's not.
Oh, okay.
Right. It was its own chapter, it's not. Okay, so it's chapter 2. And then another general thing too. On the exam, I will not ask you dimensions, whether it's old or new. Okay, so they won't get any dimension. You will get what is the largest, what is the smallest, right? So know them qualitatively, not quantitatively. So we'll start with chapter 2, right? So for example, 1 or 2 questions could be about what's the biggest, what's the smallest, right? Whether it's the biggest bacterium, whether it's the biggest virus, I'm jumping ahead, but smallest, right? Smallest free living organism would be mycoplasma, right? That is the smallest free living, and not inside the living cell. The largest bacterium, right? So for example, so again, smallest versus largest. So when you're talking about bacteria, free living, you're talking about mycoplasma. And then largest, is it clear in the back? I mean, is the ink or whatever? It looks like. Largest is, what would be the largest? Right, the Thiomargarita. Thiomargarita namibiensis. For the sake of time, we'll Thiomargarita namibiensis. Shapes. There could be, I mean, I can show you a figure that, again, it's going to be a nicer figure. This one would be this is a vibrio. You have to also know arrangements. Sorry? Okay, so this one would be a vibrio. If you see an arrangement that looks like this, right, that's a tetrad. If you see an arrangement that there's 8 of them, and again, it's going to be nicer. A packet of 8 cocci would be a sarcine, right? What's the difference between a spirochete and a spirilla? The spirochete has more twists, has more curves, right? A spirillum is much more rigid. So that is why I think, you know, having note cards or writing them down and starting, but you will be expected to know these, yeah.
Between spirilla and spirochetes, I know on like one of the exams you ask like, when does it become a spirochete? Like how many turns?
Well, usually if it's under 5, in fact most of the time 2 or 3, it's a spirillum. A spirochete is 10 or higher. So again, I'll ask you, but that goes back to my point earlier. I'm not going to ask you how many turns. I'll ask you relative, which has more turns, right? So, and again, I just have a note so that make sure I cover what I need to cover. You also have to know, I mean, there will be a lot of genera, I mean, genus examples on the exam. So for example, when we talked about take mycoplasma, right? If the organism exists in more than one shape, right, because it lacks a cell wall, that is pleomorphic, right? The other organism that we talked about was chlamydia, reticulate versus elementary body. Which organism has unusual division and snapping actually? It forms irregular Corynebacterium diphtheriae. So these are the types of questions to expect, well, at least from this material. What does this organism, which of these organisms does this? So it's not going to be much more elaborate than that. That's as far as structure and then shape. Now, as far as bright field microscopy, here again, you do not have to know the details beyond the few things that I'm going to mention here, which should be quite familiar. A bright field, right? So let's talk a little bit about bright field microscopy. Well, this sounds like Mississippi here, so microscopy. With bright field, right, I mean the field is bright, so the image is dark. Right? So, for example, I might ask you to compare two, this is microscope A, has a resolution of 0.3 microns. Microscope B has a resolution of 0.4 microns. Remember, there's a bunch of true and false, so this could be a true and false question right there. True or false, microscope A is better than microscope B. Microscope A has a resolution of 0.3, microscope B has a resolution of 0.4. Microscope A is better than microscope B, true or false? And why or why not?
False.
Why false?
Because the resolution is low.
Actually, because the resolution is lower, it's better, right? Because what does resolution mean? What does resolution mean? It
The ability
means
to
your
separate.
ability to see two distinct objects as distinct. So if you're dealing with microscope A and I have these two organisms, right? What I'm saying is that they could get closer to each other by 0.3 and I still see them as distinct. 0.4 is not as good. The lower the resolution, the better. Because that tells you that they can get closer and can still see them as apart. What is the lowest resolution? That is a magnitude you have to know, because that's not really a size per se. What's the best resolution of a light microscope? 0.2, and it has to do with how. In fact, let's change it. Let's say I told you you're looking through a 600 nanometer wavelength, for the sake of argument. What is the resolution of the light microscope, approximately?
300.
You take 600 and divide it by 2, which is 300, which is 0.3 micrometers, 300 nanometers. So really, the lowest wavelength of light is 400 that you could see. So the best resolution of a light microscope is 0.2. Objective, we have, right? We have one ocular, which is 10x. We have the 45x, the 10x, and the 100x all emergent. That's pretty much it for the light microscope, at least the bright field. Questions about now stains? There will be, and again, if it's an organism that can be stained by a particular stain, please know it. Let me give you some examples. Now, this is an example of one that will connect, I guess, more than one concept. But, well, actually, let's go in order. Let's start with stains. So, stain. So, with stains, we talked about basically, well, acidic and basic. Right, with acidic stains, the and remember, the color-bearing ion is a chromophore. It's negatively charged. And basic is positively charged. So which of these would be better to stain the actual cell? The basic. Why? Because the negative charge of the membrane will be attracted by the positive. So these are the ones that are used largely in microbiology. We can use the acidic stain to stain what?
Endospores.
Not endospores.
Capsule.
Well, the capsule is involved, but you basically stay in the background. If they can't get in, they stay in the background, right? So acidic stains are usually used for the background. Basic stains are used for the actual cell, specimen, whatever you're staining. You do have to know examples, right? Acidic, we talked about India, nigrosine, India ink, basic virtually everything else, right? Methylene blue, crystal violet, safranin, malachite green, all of these are basic stains. Is it closed? Okay, so do we know examples? So that's from here on, I'm going to focus on the basic. So let's actually, so with basic dyes, remember, you can also call them, well, not, you can also call them, they're also called negative staining and positive staining, right? So let's actually do positive staining. Positive stain. You can have a simple or differential. With a simple stain, you're using one dye and you're staining the cell. With a differential, you're using two dyes and differentiating between two cells, right? So for the differential, we're using two dyes. So what are examples of differential, real quick? Clearly, the gram stain, acid fast, endospore, like these are the big ones. Please be able, and chances are you've done them for your unknowns, so these are still clear. still fresh. With the gram stain, remember, that one question could be put them in order, right? You start out with crystal violet, you add saffron, you decolorize with ethyl alcohol, you counterstain with saffron. With the acid fast, you use carbofluoxin, you decolorize with acid alcohol, right? And you counterstain with methylene blue. Why? Because carbofluoxin is red, you can't really do saffron, it will be the same color. Endospore, malachite green, heat, and decolorize with water, and then counterstain with saffron. So that could be one question. Another question could be much more direct in the sense that, so for example, right, Mycobacterium leprae, after an acid fast stain, true or false? True, because that is an acid fast organism, it will pick up carbofluoxin. On the other hand, an endospore stain would be used for what genera? Right, Bacillus and Clostridium. What, well, gram stain, of course, we've talked about it. There's also a differential stain, right? So you can have what's called differential stains. And with differential stains, the only example we went over, don't worry about the flagellar stain. You're not going to be asked about the flagellar stain. Sorry? I'm sorry, did I say differential? This is special stains. So, I mean, it can fit under differential, but these are more appropriately called special stain. Capsule. It involves negative staining and positive staining. Positive staining stains the cell. Negative stains the background. What's left is the capsule. Right? So, I mean, that's staining. Right? So, however way you want to study it, I think this is one good way. Take a piece of paper and then start charting your way through it, or beside them, or whatever, but you will be asked about them. So questions about chapter 2. 3 is a big one. So again, if you go back to the meet session notes, but here too you will not get asked about how many layers is the gram-positive and what percentage are they cross-linked, and how many common pili are there. It's going to be relative, more thick, less, etc. You have to know the difference, right, between the two domains, first of all, right? We talked about, so start by being able to, and I think actually this was maybe in chapter 2, I'm not sure. But you know what the 3 domains, remember we have bacteria, archaea, and eukarya. So these are 2 prokaryotes. This is the eukaryotes, of course, eukaryotes. When it comes to structure, right, these 2 are close. But when it comes to molecular biology, these 2 are close. So as far as structure, this, as far as molecular biology, that. So keep this in mind. Questions about okay, so let's go as comprehensively as we can through cell structure. Okay, so this is chapter 3, starting with the capsule. Remember, going from outermost to innermost. So the capsule, basically, it's a form of glycocalyx, right? And again, don't worry about being able to distinguish between the true capsule and the slime layer. We'll focus on the capsule. It's a form of glycocalyx. What are functions? right? Attachment, protection. And obviously not the organism, right? With attachment, we talked about strep mutant. With protection, strep pneumoniae. Anything else? Protects from what? From phagocytosis, from drying, used to attach. That's it. Nothing much more spectacular. Questions about perhaps? The cell wall, you're going to get a good number of questions relatively on the cell wall because it's a big section. With cell wall, first of all, know that there are exceptions in the sense that not all bacteria, not all archaea, not all prokaryotes have cell wall, right? What would be a prokaryote or a bacterium that lacks a cell wall? Mycoplasma, right? An archaean that lacks a cell wall. Whatever. So, bacteria without cell wall. An example is Mycoplasma. Archaea without cell wall, Thermoplasma. So there are exceptions, not all of them. How can they, well first of all, what's the function of the cell wall other than to help provide shape? Protects from osmotic lysis, right? So these have to have problems if they don't have a cell wall. But they protect themselves. Mycoplasma protects itself by having extra what? The membrane has to provide rigidity. What normally provides rigidity? What provides rigidity in our cell membrane? We don't have a cell wall. Protein.
Cytoskeleton?
No, cytoskeleton is more internal support. Sterols, absolutely. Sterols. Mycoplasma has sterols. Very rare in bacteria, it has them. How does thermoplasma protect itself? By having a single-layered membrane, which is what? The tetraether. We'll talk about that. But do know that there are exceptions to the cell wall. Okay, those that do have a cell wall, in fact, let's start with the general structure. So the general structure is basically this. You have NAG, NAM, NAG, NAM, and you have a tetrapeptide. Excuse me. These are beta-1,4. Beta-1,4 linkages. And the NAM has L. So this structure you do have to know. L-alanine, D-glutamic acid, residue 3, we'll get to that in a second, and D-alanine. What is NAG? N-acetylglucosamine. What is NAM? N-acetyluramic acid. L-ala, D-glutamic acid, R3, could be one of two, and D-alanine. The links, remember, so basically there's another one that comes out, and let's do it in the reverse. Let's start with NAM, NAG, NAM, etc. NAM has the same, right? So has L-ala, D-glutamic, R3, and D-alanine. And this D-alanine would link with this R3. That's the cross link. Now normally also there's a fifth one, D-ala. When these two link, this D-ala leaves. Does that make sense? So remember, they're not really connected here. It's just, there's 5 of them. There's 5 of them here. I'm just not throwing the 5. When the fourth connects with the third, this D-alanine leaves. What is R3? Could be mesodiaminophenolic acid in gram negative or lysine in gram positive. That's the basic NAG-NAM structure. It differs between gram-positives and gram-negatives. So for example, so first of all, any questions?
What's the NAG below? Is that connected to any?
This one?
Yes, well, the NAG right there, is that connected to the D-ala right above it?
No, no.
Or,
This one?
yeah.
No, I'm just drawing two lines. So this one has a 5 coming up, and this one, so this, the NAM is the one that's connected to the peptide, not the NAM. Okay, so that's the basic structure. And now we can differentiate, and again, it's going to be essentially 20 seconds. Well, maybe more, because we're talking about gram-negative. So gram-positive, gram-negative, what's the big difference? Here it is a thick PG layer, here it is thin. Here it is very cross-linked, highly cross-linked, not low cross-linkage, low cross-link. Simple, complex. What is found here that's not there? Teichoic acids, exactly. Teichoic, this should be a T. Teichoic acids and lipoteichoic. You do not have to go beyond that detail. You know, whether it's, what is the function, etc. They have teichoic acids, these don't. Well, if these have a teichoic acid, they're thick and they're highly cross-linked, how come they're simpler? Because the complexity here resides in what? In the outer membrane. These have an outer membrane that these don't. So the complexity resides in the presence of an outer membrane. And the outer membrane, you have to be able to, right, there's many things to it. We talked about first, there's Byers junctions. Please know these. Byers junctions are what connects the outer membrane to the inner membrane. There's bronze lipoprotein. Bronze lipoprotein. Bronze lipoprotein connect what to what? Connect the outer membrane to the thin PG layer. That's bronze lipoprotein. And finally, they have the LPS, lipopolysaccharide. That itself is composed of 3 things. That's a weird linkage. But anyway, LPS has the lipid A, the core, and the O antigen. Lipid A is the toxic. In fact, that links us to chapter, the medical micro component. Lipid A is what acts as the endotoxin, specifically. Right? That's the endotoxin. The core, that's how I remember it for 20 plus years. The core is the board, basically. There's nothing interesting about it as far as we're concerned. O antigen is the one that changes between bacteria. That's the cell wall structure. There's only one more thing about gram-positive bacteria that we didn't talk about, is Microbacterium. Microbacterium has an exceptional cell wall, not because it doesn't have it, it's just because it's very different. Right? They have mycolic acid. Very few other organisms do. They have lipo-arabinomannan. They have arabinogalactan. It's in the notes, I'm not going to. So they have mycolic acid, they have lipo-arabinomannan, arabinogalactan. That allows them to resist drying, resist antibiotics for the most part, resist many different elements of the immune system. The problem is that it is too energetically unfavorable to, in other words, it takes a lot of energy to make, they grow very slowly. Questions about